Hello and welcome to our next workflow demonstration. Well, actually, this is already a second part showcasing the same scan data. And if you have missed the first part and wondering how I have recreated and reverse engineered the original plastic part, you have to go back and take a look at the first part. But this second part will be related to question how to use QUICKSURFACE slightly, let's say, designing way. And the task here is to integrate this controller into plastic housing. So that means basically all the designing around scan data is partly a reverse engineering. So basically we have to recreate at least mating surfaces. And of course, depending what you want to mate, it's a different amount of reverse engineering tasks included there. So basically, in this case, I will have to reverse engineer all the outside surfaces of this controller so I can integrate it into already existing CAD model. And as a first step here, of course, I need to actually position this controller in location where I want it to be. And in order to do that, again, I will have to create a couple of primitives or probably sketch entities or combination of both to be able to position scan data of this controller where I need it to be. Of course, first step, I'm going to use this front plane to fit here planar surface. Okay, it fits absolutely perfectly. And now basically I need to find center point of this controller. So probably the easiest way might be just to create a cross-section sketch. Okay, so how could I do that easier way? Probably I could go to Sketch Assist and say I want only rectangle. Okay, this doesn't see, well, logically it doesn't recognize this as a rectangle. But anyway, what can I do? I can go to extract primitives and say I want rectangle here, and let's try to select everything and we'll see if it will be able to fit me a rectangle properly. Well, it's not like absolutely amazing properly, but it's pretty good. We just need a couple small adjustments here. Now let's push this one. Okay, and now just this last one entity, like this. Okay, so my boundaries are perfectly within the tolerance, and I have created this rectangle here. But this doesn't give me any center point of this controller, of this sketch. Basically, I have several options. I can recreate a couple surfaces, then create middle surfaces from, for example, the top and the bottom and both side ones. Or I can actually come over here and say I want to see a middle line of those two and middle line of those two. Okay, so at this point we have intersection of those two middle lines. But thing is, there is no actually point right now, and I think currently, actually we can try to do this. Let's align by coordinate system. Yes, so I don't have any reference here that I could select as a center point. On the other side, I can use just those two entities, and it actually aligns properly as it should. But in this case, I need plane to be as a front, and I want to invert okay, let's see again. Here is some slight mess because first I didn't change orientation of my plane, so it's a little bit more complicated. Okay, and now let's flip it. Okay, now it should be good. Let's click on apply. And let's see if this is correct. Okay, so it's almost correct. I just need to flip this plane. Okay, great. Okay, so far so good. I can close that. I will just hide plane and sketch. And essentially now I actually need to position this slightly, or let's say reposition, so it's closer to front of my previously created CAD model. And from here I have, let's say, several options how I can do that. But basically I need something to reference my movement. And one option is we can simply go and edit this scan data, go to clipping box, just make it slightly smaller, approximately by half, something, whatever, like this. Accept, close, and now I can actually see where is my inner surface. As another option, we can always come over and let's say duplicate some surface. For example, this one, and this one. Hide the main body. And just use this as a reference to position controller scan data. Okay, so I will just pull it slightly closer, something like this. But I can see the top side is going slightly off, so currently, at current position, it wouldn't be like super perfectly aligned. So normally I could simply rotate it a little bit. But depending on manufacturing options and how this part will be manufactured. So if we would use something like plastic injection or similar things, it would still want to be aligned to previous coordinate system. So we have straight edges, or actually not really straight, we would need to draft them, but in the normal direction of all those previous ribs. Since this project will be simply printed, well, maybe in SLA to have like a better and nice surfaces instantly, but in this case I can simply rotate this and just forget about issues that might have come over if this part would be industrially manufactured. Of course, it could be anyway done with injection molding. Simply we would need to readjust something in main model or do some changes to avoid negative angles of surfaces. Okay, so once I have positioned my scan data, I can proceed and recreate some features of it to create, well, basically a seat for this controller. And the next step here would be, let's go and actually extract primitives again, because I need this plane since I have rotated it. And well, at this point, perhaps I should set this parallel to, no, if you want parallel, but perpendicular to ZY plane, like this. Okay. From here again, let's create cross-section sketch. Now, actually, I want to create here a slot. Like this. And I want to fit here just a straight line entity. Get rid of one side of the slot. Intersect, intersect. Probably I can add here radius for this fillet. I think I will just go with 3.5, so it's slightly smaller and there is just a tiny bit gap. On the other side, I could actually go with pretty much the same or just a little bit undersized, because anyway I will want to add some slight offset for those surfaces, so they are like not 0 to 0 fitment, but to allow it some tiny bit of slack. Basically you would be able to slide it in. Okay, let's check deviation analysis. This looks great. Let's limit it to our previously created plane. Unfortunately, I don't have backside data at the moment, so this will have to be measured for better clearance in case if I want to add some tabs on the backside. But this is not the case where I'm going to be messing with tabs. Most likely I will simply add some bracket so it can be bolted down from the backside, and that's it. Okay, so from here I have recreated basically main body of this controller. And now I can see how much space it takes and what modifications actually I have to do to this original plastic part to be able to fit it inside. And I think the easiest way for me here might be actually to hide all of this. I will simply duplicate the sketch. Let's go here. And from the sketch, first of all, actually, no, not really. I'm going simply to select everything and create an offset of, let's say, probably just a little bit more than 1 millimeter, probably 1.5. Or considering it will be perhaps printed on some FDM printer, I would like to add a little bit more of meat here and create it as an outline. Or maybe I will go with just 1.5 millimeters. It looks good enough. Oh, let's go normal to sketch. I don't need those internal entities anymore. Now I need only offsetted ones, so let's go hit and extrude. I want to limit extrusion in back direction up to planar surface that I had created for this part. Front side, I don't really care about front side at the moment, but I can see I have some entity left here, so let's get rid of it and repeat extrusion. So up to face and just like this. Okay, good. From here, I would be able to simply trim all this together, but I'm not completely sure about those cutouts, and probably I would need to keep their shape for complete thickness. So in order to do that, I'm just going to create a plane from the surface, because I think this was just a simple planar surface, if I remember correctly. And since I have this option available, it is. Okay, let's extend it. And let's do the same on the opposite side. Extend this one as well. Okay, and now I can simply trim this block with those planar surfaces like this. Unhide my solid body. Oh, okay, here is something a little bit wrong. So it's not completely the same. And the top part looks fine, so I need to do some adjustments on the bottom side. So let's undo this trim. Let's get rid of this surface. I will simply let's say duplicate those two. Hide my main body and actually I needed just one, most likely. But anyway, I can keep both of them. And I will simply trim those two. Like this. And all of them together. And this should work absolutely fine. I hope so. Oh, yeah, it seems good. Okay, and now before going to trimming, I will have to extend this surface so it completely intersects my solid block. And just let's go and trim it like this. Okay. And now I can actually go and trim those two solids. And the only thing that I want to remove is just this front part. And all the internal part I want to merge together with my reverse engineered body. Click accept, and we have one uniform body. So probably I want to get rid of those three surfaces here. Let's just delete them and fill this one so we don't have any tiny crevices or things like that. And I want to do the same on this side. Cut, delete faces, okay. Surfacing fill. Okay, looks good. So the next step from here, I'm going to unhide the model that represents my controller. And as I mentioned previously, I want to add just a little bit of offset here. Actually, I will do that with move face command with offset option enabled. So all of those surrounding surfaces, and just pull it slightly 0. I'd say 1 millimeter should be good enough. So now at this point I can simply cut this block away from my main body, and I have successfully recreated seat for my controller here. Okay, we can take a look at deviation analysis, and we can see we're pretty uniformly away from its body. Okay, great. So now one last thing that I had to do is to create a cutout to the front side of this panel. And here, unfortunately, this controller has quite stupid shape. If it would be like square on the both sides, I would be able to recreate cutout nicely that would match like a sidelines. But in this case, I will have to improvise and create something that is, well, maybe not exactly what I would like here to see. But in general, I need to solve this situation somehow. And since somewhere here is just a tiny screen for 2 digits, I will have to try to make it probably as a simple slot, maybe, to have it symmetrical. Otherwise, I don't know, in my opinion, this shape would look pretty awful as a cutout in this panel. And to recreate this cutout, I think I will just go find my sketch. Oh, yes, exactly this one. Duplicate it once again, and from here, basically, I'm going to get rid of those entities here. I will create a construction line that I will use to mirror my entity around the opposite side. And I'm going simply to connect those two arcs like this. So this would be my main outer geometry boundary of this controller. But first of all, I need some lip that would limit how deep this controller can go. So basically I need to add here some offset. Let's say 1.5 millimeter. Okay, I'm not going to need those anymore. And actually I can use this. I can try simply to extrude this and to perform cut here. Let's take a look. Okay, like this. So I have a cutout for this controller front face. And now essentially I want to add a little bit of style here because this thick surface here just doesn't seem to be pretty, and adding a simple fillet here I think wouldn't actually work that great as I would like it to be. So in order to do that, I could potentially again duplicate my last sketch. Let's go edit, let's select boundary, offset this, and this time in opposite direction, probably 2 millimeters. And this looks just fine, I think. Okay, except let's get rid of those internal ones. And now actually I want to I'll just get rid of those two as well. And now I want to slightly pull out this side of slot, get rid of this side, create again construction line for mirroring, mirror this to opposite side, and simply connect something like this. So for now I'm going to hide the scan data. And now I need to, let's say, I'll just duplicate this front surface. Good. And I'm going to trim this surface with previous sketch, like this. Hide the sketch. And now I need to pull some more geometries out of my main body. And essentially what I need this connecting surface. Let's duplicate this one. And I will simply construct plane from this selected cut face. So now I can hide my main body. What I want to do now, I want to add just a little bit of vertical surface before I'm creating a loft here. And in order to do that, I'm just going to unlock the surface, this plane, and just move it slightly, eyeballing the position where I would like it to be. Well, let's say something close to this. And at this point, I'm going to trim those two and hide my trimmed front surface. And now I simply want to loft both of them into one piece. Something like this, probably. Now, essentially, I just have to simply replace those surfaces on my main body. So by removing the surfaces I don't need here. Okay. And hiding my lofted surface and select everything, surfacing tab, choose surfaces. And we have our solid back again. And this is how it looks, this final result. Pretty much not bad. Of course, I would like to have slightly different shape cutout, but I'm limited with shape of this controller. So unfortunately, it will have to stay as it is right now here. Talking about how to fix it in position, there are several approaches. In like most, let's say, getaway, people would just glue it inside. On the other side, we can simply create some sort of extrusion to add some bolt fasteners or some screws. But in this case, I think I will leave it for now for testing purposes to see how it looks like, and after that I can figure out what kind of fastening I want to recreate for this design. Okay, thanks for watching, and hopefully you found something useful in this workflow demonstration as well, and see you in the next one.